right, so thank you so much, everyone, for coming today. We're really excited for the third installment of our historic process demonstration series. Today's talk is going to be about early silver techniques. We couldn't be doing this without the support of Art Bridges and the National Endowment for the Humanities, NEH CARES. Because of the support of these two organizations, we are able to bring you lots of different programs and experiment a little with what we're providing. So thank you so much to both of these groups. This presentation is also possible because of members and donors. Right now, particularly, we are not able to do all the things that we normally do. We're not able to hold workshops. We're not able to have on-site programs. And so the support of members and donors is really important right now for kind of filling in those gaps and making sure that we can continue to do everything that we do to educate, to collect, to share, and more. So thank you so much if you're a member or a donor for supporting us during this challenging time. So using Zoom today, if you have a question, which we will be answering at the end, please use the Q&A function. This is the easiest way for us to keep track of them, and we'll make sure to address as many as we can get to at the end. If you're experiencing a technical issue, you just want to say hi, you just are excited about something or want to share your own personal experience, feel free to use the chat function. We're also testing closed captioning today. So you'll see a CC button at the bottom, and this gives you access to closed captioning. If you decide you don't want it anymore, you can press hide subtitles. This is a beta test. We're working with one right now. It's using artificial intelligence to generate the text. So it's not the most reliable, but we figured that, we're going to start trying to do this more, and we would jump in and just see how one system worked. So feel free to give us your feedback about whether you think that this system worked or didn't work, and we should look up a new one. And thank you all so much for coming and being a part of this today. We're very excited for this next demonstration with Mark. So I will turn it over.
Oh, there's a picture there.
Oops.
There are slides, but not me. Hello. Hi, it's Mark Osterman, and today we're going to talk about really what led to photography. We'll get into photography, but what I really want to talk about is the basis of silver photography. Silver is one of the metals that the ancients knew. The metals that the ancients knew about were iron, copper, tin, gold, lead, and silver. And when I mean they knew about these metals, these are metals that you could find. You could actually find metallic copper, you could find iron ore, you could smelt these things. Out of all of these metals that were known, silver is the most peculiar, I think, because it's too soft to make a tool out of. It really was only good for ornamentation back then. And it wasn't really until you hear of the work of the medieval alchemists. So there are alchemists before the medieval times. There were some afterwards. Some of us call ourselves alchemists, although we're not looking to turn base metal into gold. But the alchemists are the ones that I think are responsible for the very beginnings of understanding how silver could be used for making light-sensitive substances. Now, here's the problem. There are books, and there's some good books. One of my favorite books is The History of Photography by Joseph Maria Ader. Ader first published his book, I think it was around 1880, 1881. There were several different editions. Ader is the go-to book if you want to know, particularly the early history of the substances used for photography. And it's not a social history, it's a technical history of photography. The problem with Ader is that he will tell a story that was told for many years about a certain person who discovered something, and he'll go through great length of describing all the things this person did. And then, well, it's kind of like asking for directions in Ireland. You'll get the directions to go down this road and then go down a little bit further. And then if you see the red barn, make a left there. And then when you get to that, well, forget everything else beforehand. Ader does the same thing. He will give you the idea that you're going to know who invented something or who introduced something. And then a little bit later, he'll say, but we don't really have documentation, or we don't really know. But at least the documentation that's there is there. So if you are good at reading Latin or Greek, he will at least tell you the sources that he used to come up with his interpretation. Now, Ader was German, and he really wants the Germans to be the inventors of photography. So just bear that in mind. The book, actually, I have a copy here. This is the most recent version, and I think this is probably from the 1970s. It's a paperback version. You should find one. It is a good read. It's dense. The first mention of using silver to mix something called silver nitrate comes around 1545. Again, these are alchemists that are playing with these different metals and discovering compounds and just doing empirical experiments. It's not known who wrote the pamphlet that describes how to make silver nitrate. But for the heck of it, I thought we should probably go through how silver nitrate is made from metallic silver. And we're going to go with the first slide then. So if you put the first slide up. All right, so this shows a coin. It's not really a coin. It's not a coin of the realm. It's not something meant to be spent. It's the way you buy silver bullion. And when I say silver bullion, it is very fine or pure silver. And if you look at the stamping on this, it says 0.999. You need pure silver to make silver nitrate. All right, next slide. And essentially it works like this. The piece of metal, in this case it looks like a coin, but it isn't. The piece of metal is put into a vessel that can stand some heat. Next slide. And then a very strong nitric acid is put into the vessel. And at that point, also there is some heat applied to start the reaction. Next slide. Once the heat is applied, you'll start to see some bubbling come off the silver in this nitric acid. The heat was needed to kind of get it going. Once it actually starts to dissolve, you don't really need the heat anymore. And eventually this process will turn kind of a copper color, kind of a brownish color. And as it just keeps eating away the silver, dissolving the silver, it gets clear again. But in the meantime, next slide, it bubbles and fizzes. And essentially what it's doing is it's turning the metallic silver into a silver salt. Next slide. Generally, what's done after that is to put water in it and clean it some and let it evaporate. The more you add water and some other things and let it evaporate, you end up with a very fine, flaky crystal that was called a salt. Now, today we use the term salt for bath salts or table salt that we put on our food. In this era, anything that was kind of a white crystal that would dissolve in water was called a salt. So what we've done is we've converted the metallic silver into the salt of silver. Camera one again. Can you start it off? All right. And so what we had is, this thing. Again, it looks like a coin, but it isn't. It's pure. And by the way, here is a coin. This is a 1923 silver dollars. The difference between these two, pure silver won't tarnish. Pure silver is soft. Coin silver has copper. And the reason they put copper into coin silver is to make it stronger so that the surface doesn't wear as easily. But what we've done is we've taken this material, this silver, here's another one. They often say, they stamped on them, they either say fine silver or 0.999 to tell you that it's pure. We've taken the silver, we've dissolved the silver, and now we have something that's a salt. It looks like this. This is, there we go. This is silver nitrate in a glass container. Here's some silver nitrate from the 1860s in the original container. Would still be useful for photography. We create something that we can dissolve in water, just what we need for doing photography. Here's the thing. Silver nitrate is not sensitive to light. Sorry, it isn't. And so if we took, let me do this. If I take a vessel like this and put some silver nitrate into there, try not to get it on my fingers. If I put some silver nitrate crystals into this vessel and I put this in sunlight, it will not turn color at all. It will not darken. But if I leave this out in this room and come back in, I don't know, 2 weeks, and then put this out into the sun, it will darken. So what's the difference? Well, it's not because the room is magical, although we do magic in this room. It's because airborne dust, organic matter, will settle on the silver nitrate. Whenever you have silver nitrate come in contact, either in crystal form or if we dissolve it in water, if it comes in contact with anything organic. Now, organic means paper. It means this wood table. It means all of my clothes. And anything that your spouse holds dear will turn dark, will turn black if exposed to light if it's in contact with silver nitrate. It must have something organic. If silver nitrate does turn dark in the sun, it wasn't very good silver nitrate. It's not pure. There's something else in it. But pure silver nitrate won't darken. In this form, in the 1500s, it was known as lunar caustic. It's called lunar because, well, the alchemists had symbols for all of their metals and materials, and the symbol for silver is the crescent moon. I think the previous one was actually a trident, 3 arrows joined at the bottom. But the one we most think of is the crescent moon. And so lunar, because of the alchemist symbol for silver, and caustic because silver nitrate is caustic. What it does is it will destroy organic matter. In the time that you would get it on your skin and your skin would turn black, it's not just that it's blackening, it's actually killing your skin cells. It's a corrosive. So lunar caustic. Now, around 1565, Georg Fabricius, I love these names, right? Georg Fabricius describes something called luna cornea. Luna cornea, the other name is called horn silver, is actually a combination of silver and chloride that are formed in a natural state. Man doesn't make it, it's something that you mine, but it's something called horn silver. And it's an important step in understanding the sensitivity of silver to light. Now, we don't really know who discovers when silver nitrate is sensitive to light. We just don't know. I'd like to assign several names, and there have been many names assigned to that, but we really don't know. But in 1647, Angela Sala observes that powdered silver nitrate, so if we take the silver nitrate and grind it up into a fine powder, it will darken when it's exposed to light. He writes that. So we know that at least he wrote that down, that it will darken when light strikes silver nitrate crystals or powder. But the man we really want to look at is a guy named Johann Schultz. Now, Schultz in the 18th century, from the turn of the 18th century, 1717, he actually goes about doing an experiment. Well, he actually finds out by accident. He's looking for something that's phosphorescent, something that will glow. And in the act of mixing things, he mixes some metallic silver in some chalk, and then he puts in nitric acid, and he shakes this up in a jar, and he has it by a window, and the side of the jar that's near the window darkens. It actually prints out black. When he realizes how it's working, and which took a long time, by the way, because he thought that well, he didn't know about silver nitrate. He just knew that he had silver in there and nitric acid. He actually had silver chloride. And the reason he had that was because the nitric acid wasn't pure, it had some chloride in it. He invented the first Etch-a-Sketch. Can I have the next slide, please? I believe it's number 7. Okay, so this is Schultz's experiment. This is one I did about 10 years ago. It has chalk or calcium carbonate. It has silver and nitric acid. And I had to add a little chloride because my nitric acid was too pure. Essentially, when you let this settle into the bottle, a stencil is put over the outside. In this case, it was black paper with stars and a moon that I cut out. And I turned the bottle toward the sun in the sunny window. And after about a day and a half, it printed this image. Schultz's experiment showed that it was light and not heat that made this incredible difference. Now, remember, he was looking for something that was phosphorescent. Instead, he got something that darkened. Now, the Latin term for this is called scotophorus. You can switch back to camera 1. The term is scotophorus, which means the carrier of darkness. All these terms are great. The carrier of darkness. And it's important because he understands that light has darkened it. All right, so by the time you get into the middle to late 18th century, around 1777, a man named Carl Scheele, he publishes the action of light is actually converting the silver nitrate or silver chloride back into metal. That's what photography is based on silver. You start out with a metal. You change this into something that's water soluble, that's a salt, and all of photography that's based on silver is based on the idea that you're getting it back into a metal again. So when you see a black and white print, the black part is silver. When you see a negative, the black part is silver. It's all about converting something that's light sensitive salt back into silver. And so he also discovers by testing and doing empirical experiments that different colors will darken silver chloride at different rates. So can we have the next slide, please? Slide number 8, I believe. And so what he does is to take a prism and break white light into the spectral colors. And by doing them with the spectral colors, exposing them through these different colors, he realizes, back to camera 1, he realizes that silver chloride is most sensitive to blue and violet light, and it's least sensitive to red. This is a really important discovery, and it plays in all throughout the 19th century in photography. It's why daguerreotypes of people with blue eyes look like they have white wolf eyes. I'm going to do some experiments here, show you some things, but before I do that, I need to make some brushes. So I'm going to make, we have the next camera, please. Yes, and I'll move over here. Camera number 2. All right, Eeny, meeny, chili beanie. The spirits are about to speak. I'm going to make a 18th century brush called a buckle brush. Now, a buckle brush is made by taking a glass tube like this, and we're going to take some cotton, wadded cotton, just like that. And we're going to insert some string down through the center of the tube. Now, these were used a lot in the early 1830s or so. Very clever little way of making a brush. I'm just going to clamp the bottom here so it doesn't pull through. And then what we do is put the cotton inside. I'll do another layer. Like so. Now, when I pull the string, the cotton will be pulled into the tube. So, like so. Like this. Now, I'm going to trim off the edge. And it makes a kind of a mop brush. Kind of feather the edges a little bit. And there you go. You have essentially a very early style of brush that can be renewed. And that's good news because you're going to be using this with silver nitrate and it will be contaminated pretty quickly. It's a pretty cheap brush to make. All it is pure cotton, so the kind that you would use for a dressing, and then some string. I'll also show you how to make a Blanchard brush, which is actually my favorite kind. It starts out with a piece of glass, and you can use any size glass you want, any length, any thickness, any width. You can make brushes of different sizes. And we take some cotton and put cotton over the edge and then fold it over the top, just like this. So that's just cotton wadding. And now I'm going to take a piece of flannel, very thin flannel, and place it over the cotton, like so. Now, you take some fine string. This is a linen string. It's my favorite for this sort of application. And you're going to tie it around, just like this. I'm usually doing this so I can see rather than a camera, so I think I'm making a brush. You'll have to tell me if it's a brush or not. Once you tie it around, maintain the tension and tie a knot. Like this, make sure it's very tight. You don't want it to come off. And there we go. Let me trim this off. So trim off the excess string. All right, and now we have a nice example of a Blanchard brush. Now, the Blanchard brush could also, you don't need to use linen, you could use a rubber band and just tie it around. The only thing is the sulfur in the rubber band sometimes can create a chemical problem. But this is Blanchard brush and a buckle brush. Let me trim that a little bit more because I'm actually going to use this. It's not just for show. Here to keep them clean. Now we're going to move back. No, actually, what I'm going to do is bring over the other table. And yeah, okay. And I'm going to show you how we're going to make silver chloride, because we're going to expose both silver chloride and just plain silver nitrate. So, get my coins in my pocket here, otherwise they'll disappear. I'm going to put on a glove. And what I have right here is a vessel, and I'm going to put into the vessel, let's see, some distilled water and chloride. Where is my chloride? Nick, in the back there's a bottle that has 2% chloride in it.
Hey, Mark.
Brown bottle.
Well, Nick was grabbing that. Could you tell us the name of the book again?
It's The History of Photography by Maria Eder, E-D-E-R, The History of Photography. The English translation is from, I believe, 1945, translation by a man named Epstein. All right, so what I have here is, all it is salt and water. Salt and water, and this is silver nitrate. Now, when I combine the two, I'm going to end up with a precipitate of silver chloride. Now, watch very carefully. See if I can get that so you can see it right like this. Pour this as a silver nitrate in water that has just plain old table salt. Like that. Now, notice how thick and how heavy. It fell to the bottom almost instantly. What's above is just water. It combines so perfectly that you have only so much silver that can combine with only so much salt. And that's what we have now, is pure silver chloride. Now, in order to do something with it, I need to, actually, you could take it that way. I need to pour off the standing water, so I have a beaker right here for that. Let me just try to pour off as much as I can without disturbing what's in here. Actually, Nick, can you give me one of the spatulas, one of the stainless steel spatulas? I can hold back some of the silver. I don't want to do it with my fingers. Now, you can see that that is very, very thick. It's very white. The stuff that I have left over is not really of any consequence. Sheila is an interesting guy. Not only does he describe what happens when light hits both silver nitrate and converts it into metallic silver, he also discovers that silver chloride is soluble in ammonia. Well, that's really important. And that'll come to play in a few minutes. It's soluble in ammonia. Now, metallic silver isn't soluble in ammonia, but silver chloride is. And so here I'm still draining. I want to get as much of this out of here as I can. That's pretty darn good. And I'm actually going to put it into a tray with a piece of paper below. You can take that. This is what we do here at the museum. We play a lot. And I'm going to put it right on this filter paper. Just so I can dissolve away or draw away as much of the water as I can. Because I'm going to need this as kind of a paste in a few minutes. All right, so this is dry here, Nick. This is my assistant. That's dry silver chloride. Now, it isn't really until 1790s when we start to see people think about making images with the idea of possibly making images in a camera obscura or in contact printing for the sake of making imagery. not just the observance that light changes these things. So the idea that you're actually going to make something that's image-based. I'm going to let this sit on the side for a second. And I'm actually going to go to the next table. Nick, you want to switch me over to the next table? We're going to do a Wedgwood experiment. Okay, camera number 2 then. And I'm going to coat, tell me if that's in a good spot, Nick. Is that a good spot? We're going to coat a piece of paper with some plain silver nitrate. So here is my silver nitrate in this bottle. I'm going to pour some into this vessel. And here's my brush. And so we're going to brush this, drawing some silver, and then just brush this on the paper using a Blanchard brush. Like I said, I like the Blanchard brush much better than the buckle brush. All right, so that's silver nitrate, and I need to dry this. So let me get my 18th century hairdryer here. It's dry enough. And now we have a piece of paper that has been coated with silver nitrate. It is now sensitive to light. Now notice that I'm not really worried about the lights on in this room because it's not that sensitive to light. But if I take this and given how Wedgwood came from the family that made the Wedgwood pottery that used lots of silhouette images, we're going to put a silhouette. What else would he have used, right? We put a silhouette. I could have used a leaf, but I like this better. Piece of glass to make better contact, like so. And now we're going to pass UV light over this. We can't go outside. It's 2 flights up, but we're going to put we're going to put the UV light on top of this. And the UV light is going to convert the silver nitrate in the paper back to metal. And the form it's going to take is kind of a violet color. Take this off, and you can see it's already starting to print. I'll leave it on here a little bit more. Let's just leave it on here for a while. Now, Wedgwood's experiments we don't really know when they were. They're in the 1790s. We know about Wedgwood's experiments because his buddy, Sir Humphrey Davy, was there and he wrote about them. And his account of the experiments are easy to find on the internet. They date from 1803, I believe. And they go into great detail of what they could have used this process for. He talks about using silver nitrate on paper, even talks about putting the paper in a camera. Now, remember, the cameras have been around long before photography's been around. So to put sensitive paper inside of a camera obscura and let it sit long enough, yeah, you could get an image. Evidently, they didn't. They didn't leave it in long enough. All right, that's good enough. So now let me show you the image. If I take this off, there you go. So this is Wedgwood's experiment, essentially silver nitrate on white paper. He also used leather. He also used wood. In the case of leather, he used white leather. Remember when people had white leather gloves, kid gloves? It's similar to that. So here is silver nitrate on paper. And you know what? It's a very elegant process. If I take this and wash it in water, it does okay as far as longevity, but watch what happens if I just expose it to light again. And I'll come back to that. Now, in the meantime, Wedgwood also used silver chloride. So remember the silver chloride I made. Now the silver chloride paste is kind of gooey stuff. It's not as fluid. It really is. It's kind of like toothpaste. Now I'm going to spread this on the paper. Like I say, it's hard to get a good coating. It's thick, very viscous stuff and kind of chalky. This is pure silver chloride. Other people experimented by just letting this stuff dry. And so if you let it dry, it will give you a powder that you could sift onto something on paper that's sticky, possibly. Okay, you're going to notice something right away with this stuff. I'm going to put a couple of gobs on it, just so you get a sense of what this stuff is like. Oop, I got some on the table. I'm not going to pick that up. Thanks. I don't know how I got those stains. Honey, here we go. I'm going to dry it a little bit. All right, so now I have paper that's been coated with silver chloride, so the compound of silver. So let's put this guy in the center again. We'll put the glass on top. And now, just for the heck of it, I'll show you, there is the picture we did before. Notice how everything darkened, right? Once we made the image and then exposed it to light, then we lost the image. And here we go. We're going to do that with this as well. In fact, I'm going to hold it above just for a little bit. You can already see that it's much darker than just silver. So let me put it on there for longer to get a sense of it. And this brings up a very important point, and that is, yes, you can make an image. You can make an image with at least, I don't know, 5 dozen things you can find at the supermarket. Anything you can smear on paper, you can make an image with. It's not about just making an image. The invention of photography is about keeping an image. Let me look at this again. Why? Let's give it a little bit more. This should show you that silver chloride is a very, very good candidate if you want to make imagery. So let me take this off, and now look at the difference between what we had. Of course, this one's darkened, but that is less exposure time than we did with the silver. And look how dark it is. It's a good argument for silver chloride, but maybe not in this form. Look what happens when I take my finger. It's thick, it's pasty, it's not even. And of course, if we expose this to light again, what's going to happen? It's going to darken. It's going to darken where we had that beautiful white silhouette, and there you go. So can I have the next 2 slides, please? Next slide. Yeah, that's the one. The reason I bring up this slide, this is a good time of year to find these things. This is a picture of my house. And if you're able to see it on the screen, if you look very carefully, you'll see that there is a frost image on the house. And that is the entire top of the roof of my house had frost on it in the morning. And when the sun came out, it burned away everywhere except for where there was a shadow. And so the shadow of the dormer on the roof that was cast on the frost maintains that shape. And everywhere else, the sun, the light, the heat, combinations of all burn away the other areas. Can I go to the next slide, please? And this one's a little bit more obvious. This is actually snow, not frost. It's from the library window of the George Eastman Museum. And so this is a very graphic example of, I call these Negro types, or Negro types in French, right? So a neige for snow. Find some of these and send them to me. I kind of collect pictures like this. And so, what we have is something that, can make an image, but we lose an image. And so when we get into the next stage of the invention of photography, can I have my camera back again? We come up to NEH. Now, NEH, all of these topics could be 3-hour demonstrations, but NEH because you know the view from the window, the point of view photograph that was made with asphalt. But before there was asphalt, NEH used a camera like this. This is essentially a recreation of one of NEH's cameras. NEH made his camera by using the lens from his father's solar microscope and essentially built a simple box. Now, just think, if we put the silver paper in the back of this, or the paper coated with that silver chloride in the back of this, and close it up and point this out a window, well, given enough time, what you'll remove from the back of the camera is a negative image. But he wasn't any farther than Wedgwood. He essentially could make an image, but he couldn't keep an image. And so he actually abandoned silver. He abandoned what led to, 19th and 20th century, and we're still making silver-based images, for something else, what he thought was better, and that was asphalt. And so he took, most of his images were not camera images. He took things like this. Now here's an engraving, and the engraving is waxed so that when you pass light behind it, you can use it as a negative. And by using this as a negative, he applied it to plates and glass and stone covered with asphalt, which turns out is light sensitive, and it's selectively hardens. But that's another story. I'm not going to talk about NEH. NEH's abandoned silver, so I'm not going to abandon NEH. So that's 1816 is when he was playing around with silver, and then eventually went to asphaltum, or bitumen, that would be the European term. When you get into the 1830s is when we really have the beginnings of real photography. One name that's lost to history is a man named Hercule Florence. Hercule Florence was really only discovered, I think it was in the 1950s. He was a Frenchman working in Brazil, and was an artist and an experimenter. And he's the guy that first uses the term photography. But we didn't know it. We know that Herschel came up with the term, but this guy had it before Herschel. He's an interesting guy because he uses silver nitrate to print pharmaceutical labels. Now that's odd enough, but what really makes him interesting is that he must have read something about maybe Sheila's work on the fact that ammonia will dissolve silver chloride. So when you make a picture and you coat something with silver chloride and light strikes it, the parts that are dark are metallic silver. Can't do anything about that. They stay black. But the parts that are not exposed are still silver chloride. And if you get rid of them, you have a permanent photograph. Some of his labels still exist. And what did he use for a fixer? What did he use for his ammonia? Urine. Right. that was the most common way to find ammonia for many, many years. I mean, the Romans used urine for dry cleaning. They started the first dry cleaning establishment. And so ammonia will dissolve silver chloride. And so he made these images, but nobody really heard about them. But again, I think it was in the 1950s. Look him up. Hercule Florence, Frenchman working in Brazil. So that's going to take us up to Talbot. We have to talk about Talbot. We're going to talk about Talbot, and we're going to end with Talbot because he's the first guy to recognize several different things. Let's see, what should I do? I should let me move these over. Take that brush. Okay, you can take that. Bring this over here. You know that we make these things up as we go. I don't think I need. Yeah, I'll take this. We come to Talbot, and Talbot is he's a brilliant guy. He's a polymath. He knows mathematics. He translates hieroglyphs, and he keeps notes of everything he does. Actually, let me have it on the bottom. If you want a good read and you're a photo geek like me, this is the book you need. Records from the Dawn of Photography. And it's edited by Larry Schaff. Brilliant Larry Schaff, if you're watching this. Larry knows more about Talbot than anybody. And I was born on Talbot's birthday. Talbot is an amazing guy, and he writes everything down. I have gone to this book so many times. It gives essentially a facsimile page of Talbot's writing, and then it's written out so you can actually read it. What this book does, these are his P and Q notebooks, is describe to you what he's thinking. He's discovering something, he's making assumptions, and then 3 pages later he says, what was I thinking? This is what it really does. So if you want to see how people experiment, not just follow instructions like I teach people, right? How to really go through the process of inventing photography, you got to read this book. And so what he does is he takes, get some paper here, he takes a different route. He knows that silver chloride is much more sensitive to light than just silver nitrate. He starts out with that premise. And so he get some of this. He discovers that the best way to do this so that he can vary the strength of both the silver and the chloride. Remember when I put them together, it found its own level and then had access to water? He found a way to change the proportions. And the way he did it was to coat the paper with chloride first, let it dry, and then coat it with a second coating with silver at a different percentage. Brilliant. So I'm going to do that. Oh, watch that. Here's some silver nitrate. I poke myself in the eye with a cork. I'm going to use our brush again. This has already been coated with chloride already and then dried. So I'm just adding the silver just to save a little time. Notice that I'm doing this under the light, like so. And of course, Talbot's hair dryer was hand cranked. It wasn't electric. All right, I believe I'm done with that, Nick. Thank you. Now we have a piece of paper, and I have it marked with a little X and pencil here, so I know which side is up. And we're going to use a better printer, a printing frame. Talbot had printing frames. They didn't open up like this. They were a little different style, but this will work. We have a real treat today because what we're going to use is, you see that? Maybe put the paper behind it. There we go. I'm actually using a botanical that I collected at Laycock Abbey. My wife and I used to do workshops there. We had a wonderful workshop called just simply 1839, where we did all the processes that were invented in 1839 so people could compare how they work. All right, so this just gives us a little better pressure, like so. And we'll expose it as well. Now remember, this is 2 coatings, one of chloride and one of silver. I'm done with these 2. There we go. Let me keep this one. All right. Yowzer. See the difference? Silver chloride is much more even because it's applied in 2 separate coats. And you can modify the strength. As it turns out, the best way to make images with this system is to start out with a quantity of salt, whatever you choose, and then 10 times the silver. So if it's 2% salt solution, it would be 20% silver. Or if it's 1.5% salt solution, it would be 15% silver. And so you now have a way, whoa, let's stop that one, to make images pretty quickly and pretty evenly. Take this out. There we go. I should hear ooh and ah. I can't hear you guys. Very, very strong image. And yet, he still has something to worry about. What does he have to worry about? How to keep an image, right? That's a beautiful image. It's a shame to have to put it under the light again. Well, I made 2 of them. I made one just before I started. So there's one that I made just before we started. And what I'm going to do is I'm going to put this one into a solution of iodine. Right. The halides used in photography are iodide, bromide, and chloride. Chloride's the easiest one to find because all you have to do is go to the ocean, get some salt water, and let it evaporate. But the effect of chloride is a little harder to see on this kind of a camera, so we're going to start with just the iodine. So this is just potassium iodide in water. We're going to pour it into this little dish. And I'm going to put this into it. Rock it around. Let me just get a piece of cotton. All right. All right, I'm not going to do this for as long as I'd like to, but I'm going to do it enough. Let me just take this out and put this on a paper towel. A little bit of stuff on here, just wipe it off. All right, and so now I'm going to dry that. Not too dry, kind of dry. And so now we have an image that it has been stabilized. Now, Talbot called this fixing, very confusing to photo historians. He used iodide, he used bromide, and he used chloride to stabilize his prints, and he called it fixing. Eventually, he went to using sodium thiosulfate, which was called hypo, right? Sodium thiosulfate, eventually sodium thiosulfate was a hyposulfite of soda. He went to that under the suggestion of Herschel and made permanent images, but he ended up with something that was stabilized pretty well. The iodide images come out with a yellow highlight. I'm not sure if you can see that on the screen, but can you put that up against there? All right. So what I'm going to do now is I'm going to expose both of these to light. I hope that happened enough. I really want to put it in there for at least 2-3 minutes, but yeah. Okay, so I'll put that on top. In the meantime, I'll show you a nice example of a print that I made, and I cut up the print so that I could dip each part into the different stabilizers. So I'm not sure what's the left and right on this, but the one that's the lightest, actually I can put my finger here. This one is the control. Or pardon me, no. Pardon me, this one, that is the control, so nothing happened to it. This one is chloride, that's iodide, that's bromide, and that's hypo. So each one gives a different color. Photography was really colorful until hypo came around, and then everything turned brown. Okay, we can take a look at this. All right, so it did pretty well when you consider it's still wet and wasn't done long enough. But there is the control. This is the one that we printed. And do they still see me? This is the one that we printed and just didn't fix, and this one was fixed in potassium iodide. I'm not sure how much time I have left, but I can show you that is an iodide-based image, and this one's 10 years old. What happened was if you use too much iodide, it would actually bleach, which led to a process called the leukotype, and also the process by Hippolyte Bayard to make reversed or direct positive salt prints. And as these things age and become more exposed to light, they have many, many beautiful colors. There is a chloride stabilized photogenic drawing. He named this process photogenic drawing. He didn't call them salt prints. Photogenic drawing for both the camera image and the print. Of course, the problem is that here's a negative. If you use this for a negative and then put it on top and shine light through it, you actually destroy the negative while you make the print. So one thing dies to give the other life. He put the same paper into his mousetrap cameras. And so here is a mousetrap camera. Open the back. That's a photograph of Laycock. Can you put that up against the lens? Maybe they can see it. Right. That's the village of Laycock made with this mousetrap camera on paper coated with alternate coatings of silver nitrate and chloride. And then, of course, he used bigger cameras as well. Like so. So I'm not sure how much time do we have?
We are already at 2.
We're what? We're at 2? Okay.
Yeah.
Well, I can stop now if there are any questions. That's it. The invention of more perfected processes came after Talbot. Talbot himself invented something called the calotype, but the use of silver chloride for paper continued to make salt prints all the way up until the turn of the century, and it's the basis of albumin printing as well. It's the same process. The only difference is paper coated with egg white. So, question?
Yes, we have lots of questions. Mainly the questions are around how people can do this at home. So we've got a lot of questions about materials.
Okay.
What type of paper are you using?
All right, the paper that I used today, what was that paper? It's a Fabriano Bristol paper. But paper is the biggest bugaboo with doing historic or alternative processes where you use paper. Sometimes papers have different additives and different sizing, but the paper we prefer for this is Fabriano Bristol. As far as doing it at home, it's no problem, but remember, silver nitrate is caustic and it stains. You don't want to do this in your kitchen. You don't want to do it in your bathroom. You need to find a place. You could do it in your garage over your cement floor or some other place where you don't care about the floor. You could do it in a big tray to try to contain things. But silver nitrate, once it lands on something, is going to give you an indelible stain forever. But it's not hard. Silver nitrate's easy to buy. You can find it on the internet here in Rochester. But the Kodak company that made silver nitrate is now run by the former employees. So there's still a ready supply of silver nitrate right here in town. And as far as salt, sea salt, kosher salt, and anything that doesn't have additives is fine. Yeah, no iodine.
When you were using the hair dryer, were you using it with a heat setting or just air?
Yeah, no, I used it with heat. Doesn't make any difference. I will say that when you coat a paper with silver and then, chloride and then silver, given enough time, it will reduce back to a metallic state on its own, meaning it will go black in a drawer if you leave it in long enough. The way this process works, remember that there's 10 times more silver than the chloride. With all that extra silver, you need that to make an image. But if you leave it with it intact with the excess silver, eventually it goes back to being metal again, and you end up with black paper. Yeah, sometimes. Depends on the relative humidity and heat.
So there's quite a few people that love your flat panel UV light that you're using. Could you tell us the make and model?
Let's see. Nick, what's the make? This is a model YQL UVFL-50.
50-watt UV light bulb. We got them from Amazon. You're going to have to order them and test them. We've had some people that bought them in Europe and they didn't get the same ones as us in America. So you have to experiment.
They aren't they originally for like DJs, right? They're for dance lights.
Yeah, you want the 50-watt light. The 50-watt is important. If you get the 10 or the 20, it's going to take even longer to print.
We have, I think we have like 8 of these. We replaced our light unit, which was a big light unit that generated a lot of heat. And we decided to try this, and we gang them up. So for each, if we have a big printing frame, we put 4 of them together. If we have 8 people and they're doing small ones, we do a line of them. They're very versatile. And you can see they print pretty quickly.
Great. So we do have a lot more questions, but I think given how late it is, I'll just remind people that if you want to email us or email the workshops team at workshops@eastman.org, they're happy to answer any questions. Again, just quickly, we couldn't have done this without Art Bridges and NEH CARES grant. So we're very grateful for the support that they've given us. There were a few questions about people wanting to know ratios and how to mix these things and kind of how to actually do it at home. If you're really interested in fully doing this process at home, we suggest that you sign up for doing an online tutorial. You can do that by going to eastman.org/workshops or contacting us at workshops@eastman.org. And we're happy to set up a one-on-one, or if a group wants to do it, a group online tutorial to actually talk through all the different recipes. So thank you so much, Mark, for another fantastic demonstration. I'm sure everyone would be giving you a standing ovation if they could today. This was a lot of fun, and thank you all so much for attending. This is part of an experimental series, and so we're always trying out new video, audio, captioning systems, and we'll definitely be experimenting with our final one of the season next time. So we hope that we will see you again for our next talk.
Kate,
Thank you. Yes.
there's also a talk I'm giving for Focus 45 coming up.
Yes, so November 13th, Mark will be giving a talk Friday, November 13th at 1 p.m. You can attend Mark's talk on the photographic truth. And on December 1st,
Talk. It's a PowerPoint talk that has nice illustrations. It'll be a fun time.
and yes, our final historic process demonstration will be on December 1st. So we hope we see you for both of these. We'll be sending around a recording of this talk within the next week, and it will have links to Mark's upcoming talks so you can register then. So hope to see you all soon. Thank you so much.
Bye-bye and vote.